Hello, and welcome to the notes on parent functions and parent points for pre-cal. In calculus, it's important to be able to manipulate complex shapes and processes. So we go over these parent functions, so these 8 ones listed here, so we know how to manipulate them. The characteristics we need to know for each of those parent functions are the following. The definitions are noted here. If you saw Ms. White's video on domain and range, those were discussed a little bit more in depth there, as well as how to represent them with interval notation. I'll be using that interval notation here. But the rest of this is pretty explanatory. Zeros are the x-intercepts of the graph. You've seen function notation with f of x before. Vertical asymptotes might be a little new. They are the vertical linear divide in the graph created commonly with division by 0. And then the 5 parent points are something that we like to use in our lessons and as common math terminology, so we can transform these graphs. So you might see where this review unit is going. We'll be doing transformations very soon. And what I'd like you to do is take the characteristics given to you. You can see the domain and range and interval notation there for things like the linear function, absolute value function, and the rest of these, and graph these functions. If you get stuck, go to Desmos. That's pretty helpful. And then I also encourage you to write your own scale if you think these grids are too small. So if you need to change the scale to 2 units is 1 unit, and so on, you're more than welcome to do that. I'm going to leave this up to you for the linear and absolute value functions. I do want to provide a little bit of clarity. You see the quadratic and cubic with the reciprocal and square root functions. The reciprocal function might be the funkiest, and we need to go through, I put this error in here, and change these parent points so people would watch the video. But the parent points for this graph are going to be -2, -1/2, -1, -1, and then we're actually going to do 1 extra. So instead of 5, we're going to have 6 here. We're going to have -1/2, -2. And then you can see the symmetry in these points, how it's going to be working for the positive direction as well. We've got 1/2, 2, 1, 1, and 2, 1/2. So those are the points we're going to use for our reciprocal function. There is a vertical asymptote here, which will delineate with this dashed line. I like to use multiple colors in my notes regularly, and if we were in class, I would have colored pencils for you guys when we're graphing. So if you like to use colors, now's your time to bring those out. I'm going to graph these parent points and plot them, and I'm going to change my scale as well. I'm a big proponent of manipulating what you have to fit your needs. So if you don't like the way this is portioned, as long as you label it properly and are careful and you've communicated it effectively, then that is fine by me. So I've changed my scale to be 1 unit is 2 units. And with the graph, that'll make it easier with the parent points. It'll make it easier to graph all of them. So -2, -1/2 is right here, so on. We can graph the rest of these. And the reciprocal function is kind of satisfying to graph because it has this nice symmetry across the origin. So while we're graphing this one, the features of these graphs and the characteristics of them, like the vertical asymptotes, they're all very unique. So it's important that you keep them distinct in your head. Ooh, and I'm using a mouse here. Oh, we almost made it all the way through as a smooth line. Cool. So I'm just making sure I'm adding on the arrows, which you should include too. All right. So now that we have turned my blunder into a nice little Easter egg for the people watching, the square root function is next for you. I'd like you to do that one. You will not have to change your scale if you want to keep it 1-to-1, so you can fit all the parent points in there. And then moving right along, the exponential and logarithmic functions will take a little bit of your time to make sure the scale is right. I'm not looking for perfection, so if you're graphing, when it comes to like making 100 tick marks inside one unit, if you're plotting to 100, then you can count out 10 spaces here and plot your 100 if you're calling every unit 10. That will work, and then you can make your scale really small. Your y value of 1 will be really small down there, but it'll work out and it'll have this exponential graph. It's really important that we are just focusing on the characteristics, though, as well as what the points could be for these two graphs, because if you've noticed, I've described the functions with multiple variables, meaning that we could use a different base. So if a equals 10, then our scale has to be pretty funky to include all these points. But know that the parent points could change to be something like -2, 1/a squared, for example. And we'll get into what makes these parent points when we revisit exponential and logarithmic graphs. For right now, I'd like you to focus primarily on these sections when it comes to these two graphs. So these first 4 sections, not necessarily the parent points here, because they're subject to change depending on the specific equation. I've also attached some images of graphs here, so you can create flashcards if you want to just look at the graph and then remember all the features of it, because we will be having a quiz on something like this in the future. So make sure you're very comfortable with your parent functions and the information spelled out in these charts. With that, I will see you all in class. Have a good one.